Okay, so today we're going to be getting into solving radical equations. That was what us going through and being able to simplify those roots easily helped us out with. All right, so finish getting that stuff down, and we'll try a few of these problems, and we should be good to go for today. Okay? All right, an equation that has a variable under the radical sign. What's the radical sign again? Yeah,
Square root sign?
Yeah, the square root symbol, right? An equation that has a variable under the radical sign is called a radical equation. All right, let's go ahead and try it. Here we go. So, to begin with, on our assignment here, set 1, solve each radical equation, show all your work, and check your solutions. Underline check your solutions, because what's going to happen as we keep going into this is we're going to get these things called extraneous solutions or extra solutions. Okay, anytime you start squaring different parts of the equation, you can get these extra solutions. So we want to double check our work just like we would do in any other problem, but checking them out. So the first step here, tell your neighbor what the or how to undo a square root. Okay, let's say you have the square root of 9. What's square root of 9? 3. How do you undo square rooting 9 to get back to 9? If you're at 3, what do you have to do to get back to 9? Yeah, times it by 3 or square the number. So to undo a square root, what we do is square it. Okay? The opposite of taking the square root of something is squaring it. And that undoes it. Okay? So whatever we do to one side, we have to do to the other. So the square root of x squared, or if you want to think of it in expanded form, kind of like we had been working on. What's root x times root x?
X squared.
It's root x squared, which is x. Okay? They just cancel each other out. All right? That gives us x, and 8 squared is?
64.
64. Okay?
Oh,
okay? And you put the 64 on. Okay, the square root of 64. Put that in there for the x. Does that give us 8?
Indeed it does.
So we're good to go. Now, I want everyone to go through the first step on number 2. Actually, try the first 2 steps there. See how you do. Sharing with your neighbor, what was the first thing we had to do? Charlie. Square the square root. Kelly. Subtract 2. Quit talking. Thank you. Subtract 2, we get root x. Root x equals? 5. How do we get rid of the squared? Everyone? Square it, yeah. That wasn't everyone, but good job. We square it. Okay? We square both sides. Square that, and we square that. Okay? So now you're left with what on this side? X. What's over here? 25. All right. Very good. I want everyone to complete set 1 there, please. Oh, hey, okay. After we started working, I had 2 good questions that came up. First, like on number 3, do you take and square both sides first? No, you have to get the radical alone on one side first. Okay, so the first step is to do what here?
Combine our terms.
What's that? Yes, subtract 1. You can't combine this and this. One's under the radical and one's not under the radical. Okay, so we've got to move this 1 over first so we can get the square root all by itself. Once you have the square root on that side, okay, when I say all by itself, I mean the square root and the stuff under it. Now you square both sides. Okay? And then on this one, the question that came up on number 4 was, is the square root all by itself? How many say yay? How many say nay? How many have no idea? Okay, tell your neighbor why or why not. Why or why not you think the square root's by itself. Discuss it there.
Raise your hand for that.
Okay, can someone tell me why it is?
Devin said it was.
KK? Good, there's nothing outside the radical. Everything's underneath the radical. So the radical's by itself. So we just kind of ignore what's in the radical right now. So if we were thinking about this problem, like I'm going to let everyone remember what's in there. And I'm going to cross it out. Okay? If you cross out what's inside and all you see is a square root symbol, it's all by itself. Okay, think of it as a box being by itself on this side. Okay, we have a square root equals 6. Okay? What does that square root have to be, by the way? Square root of what? 6?
36.
36. Okay? Square root has to be 36. Whatever's in here. Well, what was in there?
3x plus 6.
3x plus 6. Okay? Well, in order to show that, what we do is we square both sides. And notice when we do that, we get 3x plus 6, the thing in there, has to equal
36.
36. And that's what we just said. The thing in there has to be 36.
Gotcha.
Okay?
That's the answer? No, Peter.
Is that the answer? So did we solve for x?
No.
No. We got to solve for x now, right? Finish up the problem. Subtract our 6's. Divide by 3. And we get there.
We'll solve it, Joe.
All right, keep cranking through them. And set 2, volunteer on what we do first. Or what you think we do. Kylie, what do you got? Yeah, we're going to get rid of that radical by squaring both sides. Right? We got a root on both sides. So when you have a root on one side, you square both sides to get rid of it. When you have a root on both sides, squaring ends up getting rid of it. Whatever you do to one side, you have to do the other, and that's good because it takes away that radical. So root x squared is what? X. And root 2x minus 5 squared is 2x minus 5. And that convenient, the roots disappear. Now we've got to collect our x's on the same side. Did I mess up? No, it would be 2x. It's just whenever you square something, it just cancels out that radical. You're not squaring the numbers inside, right? Here. So, hey, good question. For those that are getting confused with that, because I saw about 5 of us kind of dip our heads on that one. So let's, root 2x minus 5 squared means root 2x minus 5 times root 2x minus 5. Right? We're squaring that. We have 2 of those. So if you think back to an easier problem, say like you had root 3, and you square it, root 3 times root 3 is root 3 times root 3?
3.
Is root 9. The square root of 9 is? 3. Just like we've been working on the last week. Anytime you multiply a root by itself, you get the thing that's inside of it. So when I multiply a root by itself, the thing that comes out of that root is the item that's inside. So this piece is the part that drops out. Okay? So I get x equals 2x minus 5. What now, Charlie? Yeah, we're going to collect all of our x's on one side. Okay, so Dylan, what am I left with on this side?
Negative 5.
Negative 5.
X equals 5.
Okay. KK? Over here?
Negative x. So you times the 1. Yeah, negative.
X minus 2x. Good, negative x. So if negative x equals negative 5, x equals 5. We should plug it back in. We put 5 in, that gives us root 5. Root 5 equals 10 minus 5, or root 5. Good, so we're good there. Double check your work at the end. Make sure it works out. KK.
On number 9, in the first section, so you're supposed to just leave it at 2x.
So on number 9 on the first section, when you square it, yep, you just get the thing that's inside there. Correct. You're not actually squaring the numbers in there. A square, when you square a radical, they just cancel out. Okay, so that's something to add to your notes there. Show it in your notes so when you reference them later at the end of the chapter, you have something you can study on that. All right. Everyone try number 12 if you haven't done so already. It could be. So let's check number 12. Square both sides first, right?
Yes. Right.
What do we get on this side?
X plus 1.
Good. X plus 1. And over here?
2x minus 3.
2x minus 3. Good. Next step. Raise your hand, please. You got it, Peter?
Subtract 1, move it over to the negative.
Okay.
So I'll make it negative 4.
Could subtract 1. That gives us what on this side?
X.
X. And over here?
2x is negative 4.
2x minus 4. Now what do we do? Taylor? Subtract 2x. Collect all the x's on one side. Good. So we get negative x and negative 4. So positive x is? 4. Now when we plug that back in, what's 4 plus 1?
5.
Good. So we get root 5 over there. And what's 2 times 4?
8.
2 times 4 minus 3? 5. So we get root 5. Root 5 equals root 5, so checks out. We're good. Okay, any questions on that? Okay, go ahead and finish set 2. When you're done with set 2, I'm going to have a factoring review we're going to be working on, so you can just kind of close your packet up for now. Hey, just so you guys understand why we're doing the factoring review, this is set 3. And in set 3, you've got to go through and square each side to get rid of this radical, but when you square each side, what do you get on this side? X squared. And over here you get?
Whole number.
X plus 2. So you get x squared equals x plus 2. Well, that's a quadratic, and the way we solve quadratics is to?
Square. After equals 0. Set them to 0.
Okay, we could use the quadratic formula or factoring. And the quicker way is? Factoring's the quicker way. So we're going to practice factoring. So taking a look at this sheet right here, we're going to go back and review factoring real quick. So remember, the first step, set it equal to 0, which we've got here. Second step, remember using Lizzie's method with a diamond here? We did A times C. What do we do down here? B. Two things that multiply to make 1 times negative 14 or negative 14 and add to? Negative 5. So we try 1 and 14. Does that work?
No.
No? 2 and 7?
No. Oh.
2 and 7 seems it could work. We have to switch. 2 times 7 is positive 14.
Negative 7 and 2.
Negative 7 and 2 in a cool voice. Okay. Negative 7 and 2, and then we set up our parentheses, right?
Indeed we do.
This is?
M.
M. This is?
M.
M. Minus 7 and?
Plus 2.
Plus 2 equals 0. That part gives us m minus 7 equals 0. We set that equal to 0, so m has to be?
7.
7. And here, m plus 2 equals 0, so m has to be?
Negative 2.
Negative 2. So our solutions are?
7 and 2. Negative 2.
7 and negative 2.
Good handwriting. I'll show that good handwriting.
All right, try number 3.
On which one?
Thing to remember when factoring on number 3, greatest common factor. What comes out of 2, 2, and 12? 2. 2 times what's 2m squared? M squared. 2 times what's 2m? M. And 2 times what's negative 12?
Negative 6.
Negative 6. Good. And now we have to factor this part of it. Okay? All right, let's start working through that page. I'll help you with the A's, the ones with A terms here in a minute.